Testing and fault tolerance. This presentation is on digital logic and design. The topics highlighted are test generation and fault-tolerant design. Testing overview. There are two major aspects: test generation and fault tolerance. Test generation is the process of creating test patterns to detect faults in digital circuits. Fault tolerance is the process of designing systems that continue to operate despite failures. Fault models. There are three types of faults. The first one is stuck-at faults, where a signal line is permanently stuck at logic 0 or logic 1, also denoted as S. 0 or S. 1. The second type is bridging faults, where unintended connections happen between signal lines, causing short circuits. The third type is open faults, where broken connections occur in circuit paths due to wire breaks. Test generation methods. There are two types. The first one is exhaustive testing, where all possible input combinations are applied. It requires 2 to the power of n test patterns for n inputs. The other method is targeted testing, where tests are generated for specific fault models using automatic test pattern generation algorithms. Automatic test pattern generation algorithm example. The following code shows D algorithm steps. First, sensitize the fault. Second, propagate fault effect to the output. Third, justify internal values. Fourth, generate test vector and return it. Fault tolerance techniques. There are 3 techniques to consider. The first one is redundancy, where critical components are duplicated. An example of this is triple modular redundancy. The second technique is error codes, which are used to detect and correct errors. An example of this is Hamming codes. The third one is graceful degradation, where partial functionality is maintained, resulting in fail-safe operation. Triple modular redundancy. The same input is given to 3 modules. The output of the 3 modules is given to a majority voter. Finally, the output is taken from the majority voter. This way, if one of the modules gives the wrong output, the majority voter will correct it. Design considerations. There are 2 design considerations. First, area versus reliability. Hardware overhead should be balanced with fault tolerance using cost-benefit analysis. Second, test coverage. Fault detection should be maximized with minimal tests using coverage metrics. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.